Welcome back again to Apache Kafka series. In the previous video, we have looked into producer client, and also we have connected our producer client that we wrote using Java programming language with Spring Boot and Spring Kafka library. We connect our producer client to the Kafka brokers, and then we also produce messages to Kafka broker, and also using the console client, consumer console client, we have consumed the message. So as we did in the previous video that we wrote our client using Java, also in this subsequent videos we are going to write a Java client or Java consumer client that will consume messages from Kafka to and write them to anywhere that we want. But before we go into writing the code, first we'll look into the in-depth of consumer client. Also, how does it work and what are the ins and outs of consumer client? So one of the things that we have not talked previously, it is the concept of consumer group. So you can have multiple consumers that subscribe to a topic, and these consumers belongs to the same group or to the same consumer group. And each consumer in a group will receive messages from a different partition. One of the advantage of this is that you can scale up the consumer groups. So for example, you can have a consumer group. As you can see on the diagram, we have topic 1 and we have consumer group 1. In topic 1 we have 4 partitions, and in consumer group 1 we have 2 consumers. At the beginning, each consumer now is consuming 2 partitions from the topic. But let's say we want to scale up. What can we do? We can then add more consumers to the consumer group. As you can see in the diagram, the 4 consumers are assigned partition 0 to 3, but the 4th consumer is not assigned anything because one consumer can consume one or more can consume messages from one or more partitions. Be careful of how many partitions you have and how many consumers are in that consumer groups that are processing the partitions in that topic. So we also have the concept of multiple consumer groups. What does this mean? The previous scenario is that we are scaling up. We want the consumers to quickly process the messages from that topic. But in this case, we are actually creating different consumer groups for different use cases. So one of the characteristics of Kafka, unlike other messaging systems, is the ability for many consumer groups to subscribe to the same topic and process the data for different use cases. Let's say you have a consumer group that get the same message, but in this case, they send notification to customers. And you also have another consumer groups that get the same data, but in this case, they run the statistic and all kind of data science using the data that they read. So now you have 2 different consumer groups that consume from the same topic, but using the data for different scenarios. The consumer groups has to be, or the consumers for those use cases has to be from different consumer groups. Then next we have partition assignment and rebalance. How does partition assignment works? To join a group, the consumer send a join group request to the group coordinator. When a group is created, a Kafka broker is assigned to that group as the group coordinator. And we also have group leader. The group leader is the consumer. So by default, the first consumer to join the group will be elected as the leader of the group. So the leader gets the list of all consumers in the group from the group coordinator. The group leader will use a partition assigner to decide and assign partition to consumers. Same things happen also when consumer shuts down or crashes or rebalance happens or another consumer leaves the group. When the leader got the assignment of the partition, then the leader will send the list of assignment to the group coordinator. So the responsibility of the group coordinator now is to send this information to all the consumers in that group. So this is what happens. And also we have like types of rebalance. What happens when a consumer shuts down. And here we have two types of rebalance. The first one is incremental rebalance. Let's say a consumer A is consuming 3 partitions. So, and a new consumer joined the group. Then the leader will send a message to consumer 1 or consumer A that a subset of its partition will be taken. Let's say partition 3 will be taken away from you. So then this consumer stop consuming this partition and give up their ownership in them. So when a consumer get this information, it stop consuming the partition and give up the ownership. Then in the second phase, the leader or the consumer group leader assign this new or orphaned partition to the new owner. So the new joining consumer now will get this partition to continue processing. We also have eager rebalance. With eager rebalance, during an eager rebalance, all consumers stop consuming their partitions. So the leader send information, we are going to rebalance. And then all the consumer will say, okay. Then they will all give up their partitions. And when they give up their partition, actually they also leave the group. Then they rejoin the group again. And when they rejoin the group, the partition leader will also use the same procedure as it uses before with the partition assigner to assign partitions to all the joining consumers. So now all the joining consumers will get the new partition, brand new partitions, and then they will start processing. We also have a concept of heartbeat in consumers, because how does then the broker keep track of which consumer is down or which consumer is alive? So that is when the heartbeat comes in. Consumers send a heartbeat to a group coordinator in order to maintain membership and ownership of the partition that is assigned or are assigned to the consumer. So this consumer will, let's say after every 10 milliseconds, will send a heartbeat that saying like I'm alive, so that the group coordinator will say, okay, you are still our member. The group coordinator is a Kafka broker, as we said, and this broker can be different for different consumer groups. So it does not mean that one coordinator will be used for all the consumer groups. No, another coordinator can be used for different consumer groups. The heartbeat is what makes the consumer to be considered alive. If the consumer closed in a normal way, normally a consumer then will send a notification to the group coordinator and said that I'm leaving. And immediately the group coordinator got this, it will trigger rebalance. Everything or all the partitions will then be reassigned, and then the consumers will get new partitions and they start consuming. And we also have the concept of static consumer group member. What does this mean? In normal basis, a consumer joined the group and immediately the consumer is down, then the partition will be rebalanced and will be assigned to another consumer to continue processing. But in some cases, maybe you don't want immediately a consumer shut down or fail, then the partitions to be assigned to another consumer to continue processing them. Maybe you just want this consumer to be processing those partitions, unless if there is a very critical problem that the consumer cannot come up again to continue processing, then only then those partitions will be assigned to another consumer. Well, in this kind of scenario, then what you got to do is to configure your consumer to be a static consumer. How does that work? There is a property called group.instance.id. You can give a name or something, a string value. When you give this, immediately that consumer join the group, then the coordinator will see it as a static member. What does this mean? When it joins the group, as every consumer, a rebalance will happen and partitions will be reassigned again. So when this static consumer got its partition, let's say, for example, for no reason or due to something else, the consumer shut down, the static consumer. When the static consumer shuts down, it does not automatically leave the group. So the static consumer will also appear as if it is still in the group. So for that reason, the partition assigned to that consumer, static consumer, will remain intact. These partitions will not be immediately assigned to another consumer to start consuming them. So if it is back in time before the session timeout, because there is another also property called the session.timeout.milliseconds. So before this session timeout, whatever is set to it, before the session timeout, if the static consumer is back, then it will just continue consuming its partitions. But if the static consumer is not back, then when the session timeout millisecond ends, then those partitions will be assigned to another consumer. But for example, let's say after this partition are assigned, rebalance happen, partitions are assigned, then after, let's say, 10 minutes, the consumer again is back. Then because it is back with this ID, the Kafka, the broker coordinator or the coordinator will identify it as, okay, you are a static member. We already know your partitions. So these are your partitions. Take them and continue processing. Also, rebalance will happen and it will continue processing those partitions. So this is actually the advantage of static consumer. But also you have to be very careful, because if you put like a very long session timeout milliseconds, then the message will be lagging. Then the consumer will be lagging behind for messages, or that those partitions that are assigned to that consumer will have unprocessed messages, so it will lag behind. We will continue in the next video.